Okay, yesterday we talked about how to write the orbital notations for the different elements, and today we're going to add just a little bit to that. We're going to talk about how we can come up with a set of numbers that will describe the position of that very last electron that we're drawing for the element. So we're still going to be looking at notes 41. We have our three examples already worked out with the orbital notation. In case you've kind of forgotten how it was that we came up with this, remember we're always just starting at the very top left-hand corner on our periodic table, and we're just listing all of our sublevels going across from left to right, all the way to the right each time, until we get to the sublevel that has our element. So for iron, our element was in the 3D sublevel, so we just started at 1s in the top left-hand corner and just worked our way across each time. And as long as you just follow the order that's on this periodic table, then you'll always go in the correct order. Just be sure that once we get to 4s here, remember it kind of goes in a different order. We go to 3D because of that overlapping, and then it goes back up to 4p. And it just go left to right every single time. So what we're going to do today, we're going to look at the very last electron that we drew here for nitrogen. So the last electron that we drew in this last sublevel was this one. And the way that we come up with the very first quantum number is we just look at the energy level. That electron is in 2p, so that means that our first quantum number is a 2. So that's where that number comes from. Our second quantum number will come from which type of sublevel we have, whether it's S, P, D, or F. If it's an S, that number is going to be a 0. If it's P, it's 1, D will be 2, and F will be 3. It just increases by 1 each time. So we have a P sublevel, so that second number is going to be a 1. So if you want to put yourself a little reminder, the second number, that's how we figured it out. It was P, so it was 1. Okay. For our third quantum number, we have to think about a number line. If I'm going to draw a number line, what's this number in the middle going to be? 0. Okay. The middle of our number line is 0. What type of numbers do we have to the left? Negative. So if I have one more spot over here, that would be -1. If I had another one, -2, and it would keep going. On the right-hand side, I have the positive values. But the center one is always going to be 0. And that's how we're going to find this third quantum number. The middle position here is 0. And then this would be -1 and +1. Our electron that we're looking at is in which spot? +1. And we do have to put the plus sign. And then the last quantum number all has to do with which way that last electron is spinning. Is it spinning up or is it spinning down? And this one's spinning up. And do y'all remember what we're going to put? Okay. Look on your worksheet and look up in the top right-hand corner. There's a little box, and it's going to tell you how to solve for each one of those, and it is going to be +1/2. And those are the 4 quantum numbers that would describe that electron in the last position for nitrogen. So if I had just the quantum numbers, I could work backwards and come up with the electron configuration for it and what element I had then. Okay. So let's try another one. Make sure we got it. We've got iron. Our very last electron. What was the last electron we drew here? This one here? This one over here? Yeah. Because when we filled these in, we went 1, 2, 3, 4, 5. Every empty one gets an electron. And then that 6th one, we had to go back and fill in right there. So this one facing downwards is the one that we're looking at. How do we come up with the first number? Yeah. So our energy level is 3. And then how do we get the second number? We look at the letter there. S, T, D. So it's 2. Remember, we listed them right up here. If it's going to be D, it's going to be a 2. And that's also in that little cheat box up at the top of your worksheet. Okay, our third number, we look at the orbital, see which orbital it's in. The middle one is 0, so this one over here on the far left would be -2. And then it's facing downwards, so it is -1/2. Okay. One more. 10. Yep, that's the answer. Those are the 4 quantum numbers. Okay. Our last electron here for 10 was right here. So our first quantum number is what? 5. It's whatever this energy level is. On your worksheet in the box, it says whatever row in the periodic table it's in, and that's not 100% correct. Most of the time it would be that, but if you just look at whatever energy level it's in right here, that number is going to tell you what that first quantum number is. Okay? So then it's P, so the next number is 1. And then what position is that in? 0, it's in the middle. And it's facing upward, so plus 1/2. Yeah. So I'm going to do the first one on the worksheet with you also, so that'll leave 3 of them for you to do on your own. Okay. So on your worksheet, we already worked the first orbital notation example together. So for the quantum numbers, and again, if you didn't know what I was talking about earlier, on your worksheet you have a box up here. It says start with positive. That's wrong. It should be start with negative, but yes. So we're going to write our quantum numbers for this last electron on lithium. What's the first one? 2. The second one? Now, there's only one position, so what is that number? 0. Anytime it's an S sublevel, the orbital value will also be 0. So it'll always be 2 zeros in the middle like that. I'll re-explain it here in just a moment. And then the last one is going to be what? Plus 1/2, because it's facing upwards. Okay. So you have 3 more examples. If you already did the orbital notation and it was in this spot over here that says quantum numbers, that's fine. Just fit somewhere in the space those 4 digits for that last electron.